I feel the power of chemistry surging through my bones. It's time I redo this multivalent ionic compound video. It's been a while. Let's get some different, like some color and stuff into it. Multivalent ionic compounds begins with understanding what the heck multivalent means. All right? Multi means, well, what do you think? No, I'll teach you. Multi means many. How do you like that? Did you like the suspense? Okay, I won't be suspenseful. Valent means the electron configuration for a valence shell. Now, let's take an example from your periodic table, number 26, iron. If you look at iron, underneath you'll see a 2 plus or a 3 plus charge. Now, usually metals or cations only have one. So what the heck does it? Well, this should make sense. These, okay, we have 2 or 3, that's the many. And of course, the positive charges, that's the different valence electron configurations. This tends to get my students all crazy. Like, what the heck is going on? Okay, I just want to do simple ionic compounds. So if you haven't watched that video yet, go back and look at it because the rules are very the same. All right, that's where you just need to stop everything. It's okay. It's going to be fine. We have this definition that doesn't help sometimes, but let me help you. Okay, so let's start with an example. Okay, we're going to look at an ionic compound, a name, and we want to go to its formula. So the example here is you're probably going to see it on a quiz, right? Iron, Roman numeral 3, oxide. So the first thing that calms people down is that the same simple steps as naming simple ionic compounds. And those steps are 1, write down the symbols and the charge number. 2, you cross down the charge numbers. And number 3, you reduce and rewrite. Now the same steps exist. The thing is, you have to learn to recognize where the multivalent metals are. Now, you'll notice something new in this name. It's right here. It is the Roman numeral 3. That is an indication that you have a multivalent metal. Now, in the name, I'll show you what that actually means. So we have, let's following the steps here, like naming a simple ionic compound, write the symbol. Iron symbol, Fe. Oxygen symbol, O. The charge for oxygen is 2. Which one do we use? Because on the periodic table, remember it says iron is a 2 plus or a 3 plus charge. Well, that Roman numeral actually tells us, see that's a Roman numeral 3? That is what we use in place for the charge. So really, just to recall here, that Roman numeral 3, right here, this Roman numeral tells us the charge of the iron. And that's it. And then now it's business as usual. So here's the cross down. Let's cross that 2 down there, that 3 down there. We have a 2 over here. We have a 3 over here. Now let's reduce, rewrite. Can 2 and 3 be reduced? No. Good answer. That's the correct answer. No, they cannot. So now we just need to rewrite it. Fe2O3. And here we have the formula. So remember, this is the new charge. Let's try a couple of examples real quick. Manganese 4 chloride. Symbol, manganese, and Cl. Mn and Cl. What's the charge? Well, we have the 4 is right there. Chlorine is a 1. We'll cross the 1 down, the 4 down. We'll write down 4, 1. Can't be reduced, therefore let's rewrite it because it's now has these purple arrows all over the place. MnCl4. That's it. Now, one of the biggest mistakes is sometimes people will say Mn4Cl, right? Like an Mn4Cl. This is the charge of the cation, not the number of atoms in the formula. Let's take another one. Example, gold 3 phosphide. Symbol for gold, Au. Symbol for phosphorus, P, with the charge of 3. We take the 3, see that 3, the Roman numeral 3, that is our charge for gold. We don't have to worry about picking which one because the name tells it all. Cross down the 3's, these ones can be reduced. In fact, we can divide this by 3 and that by 3, right? These two numbers, and this turns into a 1 and this turns into a 1. Never write 1s in a formula. And what do we have? AUP. That is your formula. So I feel as though that this first name to formula is kind of easy because it's the same thing as we did for simple ionic compounds. It's when we get to the formula and we want to get to the name where it gets tricksy. How do we know which Roman numeral to use? So we have NiCl2. First thing you got to name is the same rules for simple ionic compounds, but you must include the Roman numbers to indicate the charge or the correct charge used, like we just went through. So that's the only difference here. So we got the same rules as before, right? So name the metal, name the non-metal. But now we got to put that little Roman numeral in there. It's called the stock system. So a hint, if we're going to find out which Roman numeral to use, how about you cross up instead of cross down? You see, if the charge numbers are correct when you cross up, then there were no reduced numbers, that they were not reduced, I should say, grammar style. Now there's a lot to take in right now, so watch carefully up here. We have the nickel as the metal. Name the metal, nickel. And I know it's multivalent because I looked, and on the periodic table there were 2 possible charges, and so I'm going to put some brackets there. Now, it's still we still have the nonmetal, which is chloride, right? So in essence, if this were a simple ionic compound, it would be nickel chloride. But because nickel is multivalent, we have to use the Roman numerals to indicate which charge was used. So which charge was used? Well, look at this. We put the 2 up, right? And the 1, this is invisible 1. Remember, in simple ionic compounds, when making formulas, these things are crossed down. So why not cross them back up? Now, what's the charge for chlorine? It is 1. So if that's correct, then these were not reduced, which means this, too, is the correct charge. Because remember, for nickel, we could have had a 2 or a 3. So the 2 goes up, and that is our charge in there. Very quick, but very effective. So if these are correct, if the anionic charge bringing up is correct, then there was no reducing. So here's a couple of examples that I want to show you. So Hgi2, name the metal, mercury. Check to see if it's multivalent. If it is, put some brackets down there. But we can continue as normal, like simple ionic compounds. There's iodide. So mercury something iodide. So let's try it crossing up. The 2 comes up, and this invisible 1 comes up, and guess what? They're both correct, right? Iodine charge is 1, so it means this 2 is my charge number here. That's the Roman numeral. So the name is mercury 2 iodide. Here is a trickier example, Vs2. Why is it tricky? Well, it's not tricky with the whatever it's called, the steps. Name the metal, name the non-metal. We already know that vanadium is multivalent because we checked the periodic table and it has 2 possible charges. So if I cross up that 2 and I cross this 1 up, sulfur's charge is actually 2 minus. So this 1 that came from the sulfur down, it's changed. So if this is not correct, see this 2? It's not correct. Let's look at the periodic table. Vanadium can be a 4 or a 5 charge. So where did this 2 come from? Well, let's just pretend that we're making this formula. If it's a 4 or a 5 and sulfur is 2 and we cross down, we put the 2 here, it has to be a 4. Because if this is not correct, when you cross up, if it is not correct, they have been reduced. Now, which number can reduce with 2? 4. See, we divide that by 2, and we divide that by 2, and what do we get? 2 divided by 2 is 1, 4 divided by 2 is 2, and we would rewrite the formula Vs2. So that means this 4 has to be the Roman numeral that we put in there. Now, this is tricksy, only because we have to identify which Roman numeral, the charge. But at least we can relax and know that it's simple ionic compounds and the same steps apply. So now what you need is more practice. Do about 300 of these and you'll be okay. At least let me know if you need any help. Good luck.